Alright, let's look and welcome you to Lecture 2, Naming Organic Molecules. This is just a continuation of organic chemistry, but in this particular lecture we're going to focus on actual nomenclature of these organic molecules. The essential question for this unit is basically just simply, how do you name organic molecules? Alright, so we're going to look at the different steps that's required in order to name these organic molecules by breaking it up into different rules. So the first rule for naming organic molecules is you have to identify the functional group in that molecule. Now, in the last lecture that we looked at, you were asked to learn the functional groups and the endings, the names of those functional groups and so forth, and to be able to recognize and draw them. All right. So when you look at a molecule, you must identify the functional group. That's the first thing, and that's going to put it into its classification, its family, or homologous group. All right. Then rule number 2 is that you need to identify the largest or the longest straight carbon chain. All right, and that must include, so that longest straight chain of carbons must include the main functional group in it. All right, so we'll give you examples of what that all means, but it's really important. Now, the longest, or the chain, the longest carbon chain, we give it a special stem name. And so depending on how many carbons are in that chain depends on the stem name, and you're going to have to learn these stem names. So for instance, if it has 1 carbon in it, in the chain, then we call it meth. And then 2 carbons, eth, 3 prop, 4 bute. Okay, so just like that. Now an example would be like methane. Now the stem name here for methane is going to be meth because it has 1 carbon atom in it. And then the ane part, the A and E, that's the functional group. So we always use the stem name first, followed by the functional group. And so if there was an alcohol instead of an alkane, then it would be methanol. So you would just end in anol to allow us to know the functional group. All right, and so forth. So you're going to have to learn the stem names, which is the largest number of carbons in a straight chain. That includes the functional group. Plus, you got to know the functional groups as well. Okay, so let's go on here. Let's take a look at some examples here of these ideas. Now, if you look, you'll identify the functional group, and you'll look closely, and all of these are alkanes. So these would all end in A and E, all of them. A and E is going to be the ending. Now, remember we talked about the skeletal structures, and we said that at each segment where there's a point in the line is really where a carbon is. So these all have carbons right here, carbon here, here. So you could either fill it in or just remember that at each one of those points there's a carbon atom there. Alright? So I'm going to erase that, and let's take a look at trying to determine the largest carbon chain that includes the functional group. Well, so you always start, when you count, you put the functional group on the lowest carbon. Well, since the functional group here is the same on either side, on the terminal ends, which is the terminal end is here and a terminal end here, it's an alkane, so it's very simple in counting the number of carbons here. So we're going to count the carbons. We're going to say this is 1, carbon number 2, 3, 4, and 5. And it doesn't matter if you go the other direction. If you start with 1, 2, 3, 4, and 5 in the other direction, because it's the same molecule regardless of how you flip it. Alright, so this first one looks like the largest chain is a 5-carbon chain. So the stem for a 5-carbon chain would be pent. So P-E-N-T. Okay, so pent stands for 5 carbons. And then since it is an alkane, that's the functional group, you're going to end with A and E. So this would be pentane. Alright. Now the one next to it has 3 carbons. 1, 2, 3, 3-carbon chain. So a 3-carbon chain is prop. And then the functional group again is an alkane, so it ends in A-N-E, and we get propane. Alright, starting to see how this works. Not too bad, pretty straightforward. Okay, let's look at another one here. Let's start on this side this time. So we got 1, 2, 3, 4, 5, 6, 7 carbons. So 7 carbons, so that's going to be hep, and it's an alkane, so heptane, like so. Alright, now let's look at these last two. You see if you can come up with a name for them. So go ahead and pause this and see if you can work out the name. Alright, so you should have calculated that there is 1, 2, 3, 4, 5, 6 carbons. So we know that's got to be hex. And then it's an alkane, so it's hexane. And then the other one should have been 4 carbons. 1, 2, 3, 4. And so that's got to be 4 carbons has got to be bute. And again, it's an alkane, so butane. Just like so. Alright? So that's how we count the number of carbon atoms using the stem name and adding the functional group at the end. Alright, let's look at some other quick examples using some different functional groups besides an alkane. So what if you had a molecule that was CH COH. Alright, so let's identify the functional group. It should be a alcohol because of the OH here. So we know that the alcohol's in O-N-A-L, anol, okay, or anol. So we know that that's our ending. That's got to be what the molecule's name ends in. But how many carbons are there? Well, to count, we got to include the functional group, which is an alcohol. And we always use carbon number 1, where it allows the functional group to be on the lowest number of carbon. So since this carbon right here is attached to the functional group, we'll call that carbon number 1. And then the other one is carbon number 2. So we have 2 carbons, and so 2 carbons is an eth, and then we're going to add our ending, so ethanol, and so that would be the name of this molecule, ethanol. Alright, so what if we would have had something like another carbon added to that, with an OH group. So here we have erase those numbers. Now it looks like it appears we have 3 carbons, and again carbon number 1 is going to be where the alcohol is attached to it. So we have 3 carbons, and so 3 carbons is prop, and then the ending propanol. right, and so forth, right? Now, what if sometimes our functional group might not be at a terminal end? Maybe instead we have a functional group. Oops, erase this. Maybe we have a functional group that's not attached to that terminal end, maybe somewhere near the center, all right? So here we still have 3 carbons. The question is which one is carbon number 1? Well, in this case it really doesn't matter because the functional group is going to be on the second carbon. So this could be carbon 1, 2, and 3. We just got to make sure that the functional group is on the lowest possible carbon that we can put it on. And so regardless, if we started at the terminal ends, it would be 1, 2, 3, or that 1, 2, and 3. So it doesn't matter which end we start, the functional group is always going to be on the second carbon. Alright? So how do we indicate the name of this? Well, we're going to still have 3 carbons, so we're going to call it prop, right? And then we're going to put a dash between the A and N, and we're going to put 2, and then followed by another dash OL. Alright, what this propan-2-ol, what this tells us is that the alcohol is on the second carbon. Alright, so we always, if the alcohol is not, or the functional group is not on a terminal carbon, or in other words in carbon number 1, then we have to tell ourselves what number that functional group is on. So a number is always separated by a letter by dashes. And so you're always going to use dash lines to separate numbers from letters, and that's really important. So always use dashes to separate numbers from letters. Now, if the functional group is on the terminal end, one of the terminal ends, then you do not have to use the number because it will be assumed that it's on the terminal end if there's no number listed there. Alright, so let's try another one. Let's do something like a carbon, 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 and hydrogen. And let's do like that, hydrogen. We're just going to saturate everything else with hydrogens, like so. Alright, so the first thing we have to do is identify the functional group. And so if you look closely, you should see the functional group is right here, and that is going to be a ketone. Alright, a ketone. And ketones, they're going to end in O, N, A-N-O-N-E, anome. So you can basically know what the ending is, again, because of the functional group, but what about the number of carbons? And which carbon is the functional group actually on? Well, we can remember the functional group has to be on the lowest possible carbon number. So if we started on the right hand side and worked our way over, and we said this is carbon 1, 2, 3, 4, and 5, alright, that would put the functional group on the 5th carbon. But if we went the other direction and we put 1, 2, 3, 4, 5, then it puts the carbon on, or the functional group on the 2nd carbon. Well, what is the lowest number of carbon? It would be 2. So that means that the functional group should be on carbon number 2. Alright, so how are we going to name this? Is there's 5 carbons, so that's got to be pent. And then you're going to put the slash, put the 2 slash, and then O-N-E to allow us to know that A, it's a ketone, it's on the 2nd carbon, the ketone is, and it has a stem of 5 carbons in the chain, and that's just basically how you're going to name this. Okay, write this out. Alright, so let's move on to rule number 3 now. Rule number 3 says identify the functional group and add the correct suffix to the stem. And we've kind of already been doing that. So in a way, we've already talked about carbon number 3, or rule number 3. We've been practicing it. But let's go ahead and work through these problems here and see if we can name them really quickly. So the first one, you should recognize that it's an alcohol with the OH group. And it's on the terminal end, so we can start counting from the terminal end. A number of carbons, 1, 2, and then the last one's 3. So this should be propanol, like so, right? And then the next one, the functional group, is also on the terminal end, but that's going to be a different one. It's going to be a carboxylic acid functional group. And carboxylic acids are going to end in anoic acid. Now, so we're going to start out with the functional group on the first carbon right there. It's got to be on the lowest, 2 and 3. So this is going to be prop, okay? And then the acid part, anoic acid, okay? Propanoic acid, again, prop for the 3 carbons, anoic acid for the functional group. Alright, and it's on the terminal end, and so we don't have to worry about a number there at all. The fact is, all carboxylic acids are always going to have terminal end chains, so on that. Okay, so let's look at the next one. It looks like the next one is a ketone. You see the ketone right there. And so where we're going to start counting is we're going to put the ketone on the lowest number. It looks like that would be 2. So we'd have 1, the ketone's on 2, 3, 4, and 5. So 5 carbon would be pent, 2, no, like so. And the 2 has to be there because we have to identify that the ketone is on the second carbon. Okay, remember, we don't need to put a number there if the functional group is on the terminal ends. Alright. Okay, so we got 3 more to look at. We have an alcohol again. Where the alcohol, let's put it on the lowest carbon. It looks like it would probably be the second one because we go 1, 2, 3, 4. So it's 4 carbons. So how would we name that? What do you think? Well, 4 would be bute, right? And we know it's on the second carbon, so we got to put the 2 there, and then OL. So that'll allow us to know it's on the second carbon. It's the alcohol group. And again, the dashes have to be in between to separate the numbers from the letters. Alright. Alright, so far so good, I hope. What else do we got here? We got 2 alcohols now. Now it's getting tricky. Got 2 alcohols. Alright. So how we have to do that is pretty simple. It's just that now we have to have 2 numbers. Okay. So here we have an alcohol in the terminal end, but because we have 2 alcohols, we're going to have to show that the first alcohol is on carbon number 1. So 1, 2, 3, 4. So we have to have bute. Okay. And then we're going to list the numbers, 1, and then we're going to use a comma because we always use commas to separate numbers. So remember, dashes are used to separate numbers and letters, and commas are used to separate numbers. So 1 comma 2 dash all, okay? And that's just how we would name that alcohol. So if there's two functional groups, then you just list the number of both of those function, or both of the carbons that that functional groups are on, just like that. All right. All right. Last one. We'll move on. Oh, it's an amine. So we got ourselves an amine at the end there. And so we're going to have carbon 1, 2, 3, 4. Okay, so bute. And what is an amine ends in? It's an anamine. So we're going to call this butanamine. Butanamine. All right. So this is for the amine group, and that, of course, is for the number of carbons. And notice we didn't put a number here because the amine group is on the terminal end, and there's only one of them. All right. So we're doing pretty good, hopefully. We'll do some more practice a little later. All right. So this should be rule number 4 here. So let's change that to rule number 4. Okay, on there. So rule 4 says identify the side chains or substituent groups. So what that means is sometimes we have other groups on here that are not functional groups or considered functional groups, or are not part of the main largest carbon chain. Okay, and sometimes, for instance, you have a carbon that's not part of that main carbon chain, and so we have to still include it in the name, and we'll kind of show you an example what those are. But if, for instance, you have one carbon that's not part of the main chain, then we call it a methyl group. 2 carbons, we call it ethyl, and 3 carbons that are not part of the main group, we call it propyl, and so forth. Okay. Fluorines are fluoro, chlorines are chloro, bromo, ido, so forth. Okay. Aminos, those are when you have another functional group besides an amine group. And so we'll talk about what that means a little bit later and give you some examples of those. But let's talk about how we deal with these substituent groups. Okay. So here we got some molecules here that look a lot more complex than what we're dealing with. If you look at this first one here, you'll recognize that it is an alkane. All right, an alkane. So we have to determine how many carbons are on the main functional chain, or the largest chain. So let's see if we can count and figure that out. We could go with 1, 2. If we go down to this one here, that would be 3, but certainly we can get more carbons than 3. So this one right here is not going to be part of our main chain, and we're just going to call that a substituent group there. So let me rewrite this. So 1, 2, 3, 4, 5. Uh-oh, we're branching again. 5. Do we go 6 up to the top, or do we go 7 and 8? It looks like 8 would be the longest that we could get, it looks like. So 1, 2, 3, 4, 5, 6, 7, 8 is the largest chain. And that means, what about these other carbons? Well, these are going to call substituent groups. And so we're going to have to name those. We name substituent groups first. And so if you go back, you'll remember that with our substituent groups that only have one carbon, which this one does, we call it a methyl group. So we have 2 methyl substituents. Okay, and so how are we going to write that out? Well, here we go. We got 2 methyls, and let's go back and count 1, 2, 3, 4, 5, 6. Oh, wait a minute, did I miscount? 1, 2, 3, 4, 5, 6, 7. Oh, we only have 7. So there's only actually a 7 is the largest chain, I think. Because if you count at the top, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, so 7 is our largest. So these are our 2 methyl groups right here that we need to write. Now, our substituent groups need to be counted on the lowest carbons that they possibly can be on, as long as the functional group is still on the lowest carbon atom. So if we take a look at this, then we're going to have a substituent group on the 2nd carbon, on the 5th carbon. So we're just going to write that down as 2, comma, remember we use commas in between, 5, and then a dash to separate letters from numbers, methyl. And actually, sorry, we got to add a di, because there's 2, so we're going to call it dimethyl, since there's 2 of them, dimethyl. And now we use our stem, which is the longest carbon chain, which is 7, so this is hep. And then it is an alkene, so it's heptane. Okay, heptane. So 2,5-dimethyl heptane. Again, the dimethyl is that there's 2 methyl substituent groups on carbon 2 and 5. Heptane is our largest carbon chain of 7, and the functional group is an alkane. And so that's how you would name this. I know it's really complex here, but you can do this. Alright, so let's take a look at our next one. The next one looks like it's going to be an alcohol right there. So let's see, we have to include the alcohol in the largest chain, so we're going to start on this side with 1, 2, 3, 4, 5. Now we're branching, and so if we go top it would be 6 and 7. If we go down below it would be 6, 7, and 8. So it looks like we're going to keep on going up. 6, 7, and 8. So 1, 2, 3, 4, 5, 6, 7, 8 looks like the largest carbon chain. It's an alcohol, so that means we have a substituent group. So we have a carbon, we have 2 carbon substituent groups there. Carbon here and here. So that means we have an ethyl substituent group. Alright, so we're going to, and that ethyl's on a 5 carbon, so we're going to go 5-ethyl. Alright. That tells us we have an ethyl substituent group on the 5th carbon. And then our stem is going to be it's an alcohol on the 2nd, so we've got to put a 2 and then end in all. Okay. So break it down. Our ethyl group is on the 5th carbon. Our largest chain is 8, so it's octanol. And it's an alcohol, so it ends in OL. And our alcohol is on the 2nd carbon, and so you would name it like that. Okay? So I know there's a lot there. It's pretty complex. We're going to practice a lot more of this in class, so forth. So you can see all this, okay? Ooh, this next one is pretty complex, too. It looks like we kind of have 2 functional groups here. We have a carboxylic acid and an amine group. And so what did I say earlier is that if you have a functional group other than an amine one, then the amine will not be the functional group. It will be considered as a substituent group. So the amine is just a substituent group, and the carboxylic acid is going to be our main functional group. All right. So that means we have one carbon, which is our on that functional group, 2, 3, and 4. So that means we have two substituent groups. We have a methyl group and an amino group. So the amine becomes amino. So how do we name this? With two different substituent groups, well, we alphabetize them. So what comes before would be A, so amino would become before methyl. And so this is how you would name it. We go 2 amine, 2 so we have 2 amino, and then we're going to do a dash, and then we're going to put a 2, or sorry, be a 3 methyl. I need the dash there. 3 methyl. Okay, so those are two substituent groups. The largest chain is going to be 3. So we have prop, and I'm running out of room, and it's an acid, a carboxylic acid is the functional group. So propanoic acid. Okay, it's going to be this one here. Alright? And so that's how we would do it. Our two substituent groups, 2 amino, 3 methyl. Longest chain is 3, so it's prop. And the functional group is a carboxylic acid, so propanoic acid would be our deal. Alright, so we're running into past 30 minutes on this, and so I don't want to take much more time. So what I want you to do is on your own, see if you can name these last two. See if you can come up with a consensus, and then class we can talk about it. Right? So make sure you kind of look through this video, study this, kind of get familiar with the rules and how to write organic molecules down. In class, we're going to practice this a lot and spend some time with it. So the best thing with this lecture is to get a good general idea of how to name organic molecules with the stem names, the functional groups, the substituent groups, the dashes, the commas between letters and numbers, and so forth, the order and how we put the names and so forth. All right? So that is going to be it for now.